Hello and welcome again on another video on 11 plus maths learning at home and by Arts Education Limited, and this is about HCF and LCM, and it's the first video. Right, the first question, a very popular one in 11 plus exams, that how do we find HCF and LCM of these two numbers? If you know any method, you can give it a try and I will start you off in a minute. Okay, so I'm going to pause the video. Okay, the most popular method is about finding the prime factor tree of both the numbers. We divide these two numbers by a prime number if you can. So let's say with 2, that's a 60. So 2 is a prime number, I put a circle around it and continue the tree with this, 2 and 30 and so on. I do for this as well, 2 and 36. So I write down all of them until all the numbers are written in prime numbers. So let's find the prime factor tree for this and we take it from there. So after completing the prime factor tree, we write these factors as a list and we write each number as we call product of their prime factors, and we write them as 2, that's 2, times this 2, times this 2, and so on. We write them as product of the prime factors. Once this list is ready, to find the highest common factor, HCF, we just look for the common factors in both the lists, which is this 2, then another 2, then another 2, then a 3, and then that's it. There's nothing left which is common, which is present in both the lists. And what do we do with them? We just multiply these. So this gives me 24. So 24 is the highest common factor of 120 and 72. To find LCM, what do we do, guys? We repeat the same process we do for finding HCF. That means we write HCF first and then times it by the leftovers, any factors which have not been used to find the HCF, which is a 5 times 3, and the answer is 24 times 15, which is 360. So 360 is the LCM of 120 and 72. Now the trouble is, if they ask you to find prime HCF and LCM of 3 numbers, this method can be very lengthy and very troublesome. So I'm going to teach you another method of finding HCF and LCM of 3 numbers, which can be used for these 2 numbers as well. So the question now asks me to find HCF and LCM of 120, 72 and another number 48. If I use the same method, I will write 48 as product of its prime factors, which is a 2, then another 2, then another 2, and then another 2, and then 3. Okay, then if I see the common factors in all the 3 will be a 2, a 2, a 2 and a 3, so HCF will still be 24. Okay, but now I'm going to teach you the method which I said we will. What I'm going to do in that one, people, we write all the 3 numbers, or 2 if they were you to find HCF and LCM of 2 numbers, in one line and do a short division of all of them. Okay, what is the smallest prime number you can divide these numbers with? And the answer is 2. We divide all of them: 60, 36 and 24. I hope you understand. What do? We repeat the process if possible. 2, 30, then it is 18, then it is 12. Repeat the process if possible, which is in this case 2, 9 and 6. Then repeat the process possible, and it's not, because we cannot divide all the 3 numbers by 2. So but can we think of another number? Yes, 3. So which is 5 and 3 and 2. Now can we repeat the process? And the answer is no, because all the 3 numbers are prime numbers. They cannot be divided by any other number. Right, so we reach here and stop. So HCF is the numbers, the prime numbers, which could divide all the numbers at the same time. We just multiply them. This will be 2 times 2 times 2 times 3. That's 24. Same as what we got over there as well. For the LCM, we have to continue the division. Even if you're able to divide two of the three numbers, you must, which in this case we can't. We can't divide two numbers by 2, any two numbers by 3, any two numbers by 5, and any two numbers by 7. Okay, so for the LCM, what do? We take these numbers, which we got 24, which is the HCF, then times this by the leftover numbers at the bottom, which is a 5 and a 3 and a 2, and the answer is that gives you 360 times by 2 is 720. So LCM of these three numbers is 720. The next type of questions which come in 11 plus for HCF and HCF are these types, where you have to first find out are we going to use the HCF or LCM. Then the stuff is very simple from there on. In this case, what is the smallest number that 2, 3, 6 and 10 will go into exactly? That means these four numbers will go into exactly. That means we're looking for a bigger number, and the answer bigger is the multiples. It has to be a multiple, and we're looking for the lowest common multiple. Now guys, we're going to find LCM of these numbers. We can just do one simple stuff, find out the times table of 10 and see which number can go where 2, 3, 6 and 10 all go into it. 10 times 1 is 10, 2 goes into it, 6 doesn't, 3 doesn't, so 20. 2 does, 3 doesn't, 6 doesn't, 30. 2 does, 3 does, 6 doesn't, 10 does, so 30 is the answer. Okay, if this was a harder question, if numbers were harder, you could have done the method I've taught you to find LCM. Which number can divide all of them? 2, 1. This can't be divided, so I write that as it is. Can't be divided, so I write that as it is. 2 goes into 6 3 times. 5. Which number can divide all of them? None. Find that. Okay. Any number which can divide two of them? 3. So 1, 1, 1 and 5. There's only one number left there. So LCM in that case, people, will be 2 times 3 times 5, and that is 30. So 30 is the number in which 2, 3 and 6 and 10 can go whole exactly without leaving a remainder. Alright guys, well done. Thank you very much. We catch you again in the next video. Thank you. Bye. Happy learning.